People talk about empty space as if it's nothing, a gap, a void, an absence where nothing happens. That idea is wrong. Not slightly wrong, completely wrong. Empty space is not empty. It is not quiet. And it is certainly not doing nothing while you're not looking. In fact, most of the activity in the universe happens in places where you think there's nothing at all. Atoms are mostly empty space. So are you. So is the room you're sitting in. And yet here you are, solid, stable, and not falling through the floor. That alone should tell you something is very strange about your definition of empty. If you could remove all the matter from a region of space, what you'd be left with is not nothing. You'd be left with fields, fluctuations, probabilities, and rules quietly operating whether you care or not. Space vibrates. It seethes. It borrows energy and pays it back. And it does all this without asking for permission or for you to notice. The real mystery is not what fills space. The mystery is why we ever thought it was empty in the first place. There is no such thing as nothing. Let's begin with the most misleading phrase in all of physics. Empty space. It sounds harmless. It sounds obvious. It sounds like a place where nothing is going on. And it's one of the greatest misunderstandings we ever invented. Why empty feels so natural. We learn early to associate emptiness with absence. An empty glass has no water. An empty room has no people. An empty box has nothing inside. So when we extend that logic to space, we imagine a gigantic box with stars sprinkled in it and the rest just sitting there quietly doing nothing. That picture is comforting. It's also wrong. Space is not a container. This is the first mistake. Space is not a box that holds things. It's not a stage waiting for actors. It's not a background that politely stays out of the way. Space is part of the physics. It has rules. It has structure. It has behavior. And those rules operate whether or not anything obvious is present. The atom already ruins the idea. Before we even reach modern physics, the atom should have warned us. Atoms are mostly empty space. The nucleus is tiny. The electrons don't fill the volume. And yet atoms don't collapse. They don't drift through each other. They don't behave like mist. Why? Because what you're calling empty is not empty at all. It's governed. Why you don't fall through the floor. Here's something that bothers people when they first hear it. Your body is mostly empty space. The floor is mostly empty space. So why don't you fall through? Because solidity has almost nothing to do with matter, touching matter. It has to do with fields, forces, and rules operating in space. No contact required. Fields don't turn off just because matter leaves. Remove all the particles from a region of space. What's left? Electric fields, magnetic fields, gravitational structure, quantum field. These don't disappear just because you cleared the room. They are not decorations. They are the furniture. The dangerous word, vacuum. Physicists use the word vacuum. People hear that and imagine perfect nothingness. That's not what it means. A vacuum is simply the lowest energy state of the fields that exist everywhere. Lowest energy does not mean zero activity. It means minimum allowed activity. And even that minimum is busy. Space refuses to sit still. Even in the deepest vacuum, space fluctuates. Not metaphorically. Quantities rise and fall. Energy appears briefly and vanishes. Fields jiggle around their lowest possible value. This is not optional behavior. It is enforced by the same rules that govern everything else. Why, nothing happening is an illusion. People assume that if nothing noticeable is occurring, then nothing is occurring at all. But physics doesn't care what you notice. Space does things constantly, quietly, statistically, and without visible fireworks. Most of the time, those effects cancel out. That's why you think nothing is happening. The mistake of trusting your senses. Your senses evolved to track survival scale events. They are excellent at spotting predators and cliffs. They are terrible at detecting subtle structure in space itself. So when your senses report nothing, physics politely disagrees. Empty space is full of constraints. This is the part people miss completely. Even where no particles are present, not everything is allowed. Some motions are forbidden. Some energies cannot occur. Some configurations are impossible. Those restrictions are real. They shape what can happen later. Space has memory without remembering. This sounds poetic, but it's precise. Space responds differently depending on how it has been disturbed, even after the disturbance is gone. Not because it remembers like a brain, but because its state has changed. That's not emptiness. That's dynamics. Why classical physics hid this from you? Classical physics treated space as passive, a coordinate grid, a measuring tape. That approximation worked very well for large, slow things. So we got used to it. Quantum physics removes that convenience. It shows that space is an active participant, not a silent partner. The lie of nothing in between. When something happens here and something happens there, we imagine nothing in between. But what connects those events is not nothing. It's fields obeying rules. You never interact through emptiness. You interact through structure you can't see. Why this makes people uneasy? Because empty space feels safe. It feels like a place where physics stops. Quantum theory says physics never stops, even when you're not looking. The first real lesson about space. Here it is, stated cleanly. Empty space is not an absence of physics. It is physics in its most stripped down form. And stripped down does not mean inactive. It means fundamental. Why this matters? Immediately. Because once you realize space itself is doing something, a lot of puzzles suddenly become unavoidable. Why does energy seem to come from nowhere? Why do particles appear and disappear? Why does the vacuum affect motion and mass? Why is nothing never neutral? These are not advanced questions. They are consequences of abandoning a bad picture, the comforting mistake we must abandon. We want a clean divide. Here is matter. Here is space. Here is nothing. That divide does not exist. Matter is what space does under certain conditions. Where this is going next. Now that we've killed the idea of empty space as nothing, we have to face a more uncomfortable truth. Even when space looks calm, it is alive with activity. You are forbidden to measure directly. And that leads us straight into the vacuum itself. What fluctuates there, why it must fluctuate, and why nature refuses to let space be truly quiet. Why nothing is never allowed to sit still. Once you accept that empty space is not really empty, the next question is unavoidable. What exactly is happening there? And the answer makes people nervous because it sounds like cheating. The quietest space still has motion. Physicists talk about a vacuum state as the lowest possible energy configuration. People hear that and imagine stillness, perfect calm, no motion, no activity. That image is wrong. The vacuum is not silent. It is the quietest allowed noise. Why absolute zero still isn't zero? You might think that if you remove all heat, all particles, all radiation, then nothing should move. Nature disagrees. Even at absolute zero, fields cannot sit perfectly still, not because they're restless, but because the rules forbid it. The uncertainty that forces activity. Here's the simple reason. Space can't shut up. You cannot simultaneously define the value of a field and how fast it's changing with perfect precision. That's not a measurement problem. That's a structural rule. If space were perfectly still, it would violate the uncertainty principle. Nature refuse. Borrowed energy is a bad phrase, but it points somewhere. People say the vacuum borrows energy and pays it back. That language is sloppy, but useful if you don't take it literally. Nothing is borrowing anything. What's happening is this. Energy can fluctuate for short times, as long as the rules are obeyed statistically. No permission required. Virtual particles are not little visitors. This is where pop science really goes off the rails. You've heard about virtual particles popping in and out of existence. They are not tiny objects popping into reality like soap bubbles. They are terms in calculations. They represent interactions allowed by the rules of quantum fields. Treating them like physical particles roaming space is a mistake, but the effects are real. Even though the picture is wrong, the consequences are measurable. Vacuum fluctuations, shift atomic energy levels, affect the particle mass, influence forces between objects. If the vacuum were truly empty, these effects would vanish. They don't. The Casimir surprise. Put two metal plates very close together in a vacuum. Nothing between them, right? Wrong. The plates feel a force pulling them together, not because something is between them, but because space itself behaves differently when constrained. You changed what fluctuations are allowed. The vacuum noticed. Space responds to boundaries. This is a deeply unintuitive idea. Space is not indifferent to geometry. Change the shape, the size or the constraints and the behavior of the vacuum changes. That means space is not nothing. Nothing doesn't care. Why this doesn't violate energy conservation? People worry this creates energy from nothing. It doesn't. Energy conservation applies globally and statistically. Local fluctuations are allowed as long as the bookkeeping works out. Nature keeps its accounts balanced. Always. The vacuum is not a source of free power. Let's kill this myth now. You cannot extract unlimited energy from empty space. The fluctuations average out. Every attempt to cheat fails. Nature is generous with structure but ruthless with loopholes. Why fields are the real actors? Particles get all the attention. Fields do the work. Fields exist everywhere, even where particles don't. Particles are excitations of fields. Remove the excitations, and the fields remain. 不是. Why? Nothing still pushes back. Even when you remove matter, space still resists change. You try to bend it, compress it, disturb it, and it responds. That response is not optional. It's built in. The deep mistake people make. They think physics only happens to things. Quantum physics says physics happens to possibilities. And possibilities exist everywhere, even in so-called nothingness. Why this makes space feel alive? People hesitate to say this, but the feeling is understandable. Space reacts. Space fluctuates. Space enforces rules. But it is not alive. It is structured. And structure is not emptiness. The second real lesson about empty space. Here it is, stated carefully. Empty space is the most active state the universe allows when nothing obvious is happening. And that activity is not decoration. It shapes reality. Why this matters for everything else. Once you accept vacuum activity, a cascade follows. Particle masses depend on vacuum behavior. Forces depend on vacuum structure. Stability depends on vacuum rules. Empty space is not the backdrop. It's the foundation. Why this is hard to teach? Because nothing is easier than subtle activity you can't see. So we lie gently, and then we forget the lie was temporary. The cost of the lie. The cost is confusion. People think forces act mysteriously across empty gaps. They don't. They act through busy space, where this leads next. Now we're ready for the final blow to intuition. If empty space is active, if it fluctuates, if it affects particles and forces, then we must confront the most disturbing idea of all. Empty space has energy. And once space has energy, gravity can't ignore it. That's where everything becomes uncomfortable. Why? Nothing weighs something. At this point, people usually try to retreat. They've accepted that empty space isn't empty. They've accepted that it fluctuates. They've even accepted that those fluctuations have real effects. But now comes the idea that pushes intuition past its breaking point. Empty space has energy, and once energy exists, gravity shows up uninvited. Energy is not optional. In physics, energy is not just a bookkeeping tool. It is a source. Anything with energy influences motion. Anything with energy gravitates. There are no exceptions. So if empty space has energy, and it does, then empty space must gravitate. That single sentence causes enormous trouble. Why this was ignored for so long? For a long time, physicists quietly hoped this wouldn't matter. Vacuum energy seemed like a technical detail, a background offset, something you could subtract away. But gravity doesn't let you subtract things just because they're inconvenient. Gravity measures absolute energy, not differences. An empty space refused to stay quiet. The vacuum has a baseline energy. Even in its lowest energy state, quantum fields do not sit at zero. They can't. The uncertainty principle forbids perfect stillness. So every point in space carries a small but non-zero amount of energy. Multiply that by the size of the universe. You now have a problem you cannot ignore. The most embarrassing prediction in physics. When physicists first calculated the energy of empty space using quantum field theory, they got an answer. A very precise answer. And it was wrong by an absurd amount. Off by a factor so large it makes calculators blush. This is not a small disagreement. It is the worst theoretical prediction in the history of science. Why this isn't a math error? The calculations are consistent. The experiments are consistent. What's missing is understanding. Nature clearly includes vacuum energy. Gravity clearly responds to energy. But the two don't line up the way our equations say they should. That's not emptiness. That's a clue. Space is not passive under gravity. Gravity does not pull things through empty space. It reshapes space itself. If space has energy, then space affects its own shape. That feedback is unavoidable. Why the universe isn't exploding? Given the predicted vacuum energy, the universe should either tear itself apart instantly or collapse into nothing. It does neither, which means something deep is missing from our picture. Not from experiments, from interpretation. The quiet role of the vacuum in expansion. Observations show that the universe is expanding and accelerating. Something is pushing space apart. That something behaves suspiciously like vacuum energy. Not empty, not nothing, not ignorable. Space itself is participating in the dynamics of the cosmos. Why this makes people uncomfortable? Because it means there is no neutral ground, no place where physics shuts off, no true background. Even nothing contributes to what happens next. Stop thinking of space as the stage. This is the final mistake to abandon. Space is not the stage on which the universe performs. Space is part of the performance. It bends, it fluctuates, it stores energy, it reacts. A stage doesn't do that. Why empty is the wrong word forever. Empty suggests absence, but space is full of rules, constraints, activity, influence. Calling it empty is like calling a sleeping animal dead. You're mistaking quiet for nothingness. Here it is, stated without drama. Empty space is the lowest energy, rule-filled, dynamically active state the universe allows. Nothing more, nothing less. And that state matters. Why this changes how you see reality. Once you accept this, many mysteries stop being mysterious. Forces don't act across gaps, they act through structured space. Particles don't float in nothing, they emerge from fields. Stability doesn't come from solidity, it comes from rule. The universe is not made of things sitting in space. It is made of behavior occurring everywhere. Why this isn't philosophy? This is not speculation. It is forced on us by experiments, calculation, observation. You can dislike it. You cannot avoid it. Why physics doesn't give you comfort here? People want physics to say, don't worry, nothing is really nothing. Physics says, nothing was never nothing to begin with. And then it stops talking. The irony of nothing. The more carefully we study nothing, the more structure we find. And the more we find, the less meaningful the word nothing becomes. Let me say it plainly, because this is the point everyone gets wrong. Empty space is not the absence of reality. It is reality in its most fundamental form. And everything else, particles, forces, matter, is what happens when that space is disturbed. We imagined empty space as a gap between things. Nature never agreed. There was always something there. Quiet, constrained, fluctuating, and powerful, waiting patiently for us to stop calling it nothing.